Hello, coders. Let me. Oh, sorry. Let me just. We don't need. You don't need my error in the console. Just let me get a clean interactive. Oh, it doesn't clean up. Okay, fair enough. Can I just press enter enough times to? There we go. Okay. My previous slightly defective attempts are now carefully hidden away. All right. I'd like to talk about guards. Guards. Sorry, in Haskell it's minus minus guards. Guards is the title of a Terry Pratchett Discworld novel. Guards is the function can be used defining guards. They're can be thought of. Well, okay. Guards allow you to classify behavior according to input. What this means is that instead of defining your function and the return value, you define more than one return value based on conditions. So it's a switch case type statement. So it's selection, right? Classifying behavior according to input. That's it's a 1, 2, 3, 4, 5 word way of explaining a one word concept, which is selection. Now I'm going to redo the absolute value function, which already exists in Haskell, right? Abs of 3 is 3. Abs of minus 3 is, of course, an error. Why is that? Because abs of minus 3 should be abs of bracket minus 3. Because minus is an infix operator, we expect something before it, because it's 0 minus 3. In fact, if you do ab 0 minus 3, it will work. Although what this is actually doing is ab 0 and then adding a minus 3 to that, because it's fbod mass, right? Function application or abod mass. Application, bracket, and so on. So in order, long story short, whenever you want to write a negative number, put some brackets around it. Generally put more brackets rather than fewer, right? If I want to do a square. Okay, so if I define square x is equal to x times x, and if I want to, that's pointless, but if I want to do square of abs minus 3, that's confusing. So you want, sometimes it will reject it, sometimes it will do it, but not do the thing you expect. So just add the bracket so you know what is, and again, because it's minus 3, you know what's going on. And in fact, you might, if this is within a larger expression, you may very well want to wrap the whole thing in brackets, right? So more brackets rather than fewer. You can always, like remove the redundant brackets after. Anyway, so I've got my abs. It works well. Let me define an abs prime. In Haskell, we can do that because apostrophes are allowed and even to a degree encouraged because of this mathematical notation to say, oh, it's just a slightly tweaked new version of the function. The absolute value of x is equal. Now, with that guards, you're using selection. The way to do selection is for if. So your ifs in Haskell, that you have to have an else because it's an expression that need to evaluate to something. So if x is smaller than 0, then minus x, else x. That's my absolute value. Absolute value of minus 3. Just check it's still 3. It's still very much in known territory, right? But remember, so it's a little bit, again, syntactically, it's not what we may know from procedural programming, because it's equal, and then, but this thing is an expression, and because it has an else, it will always evaluate to something, which incidentally needs to be something of the same type. We can't mix and match, as we find it here, right? This is why I need to show x to return my string in my BuzzFeed Fizzbuzz video. So that's selection by if. That's, yeah. But, and this is what we've used for Fizzbuzz. But if I want to do a very much Haskellic way of doing it, I'm going to use guard. So I'm going to need more than one line. So abs prime. Now guard, what you do, instead of doing equal, push the next line and start putting more than one equal, right? There's this idea of the guards are like, you use the pipe character. So it's kind of, imagine that you had like a vertical line to say, instead of one thing, yeah, it can be minus n, it can be n. And the syntax is the pipe, a Boolean expression that needs to evaluate to true or false. We'll talk about otherwise in a second, but that's just true. And then equal, and then the return value. And this allows you to do a switch case type selection. And like a switch case type selection, things will be attempted to be evaluated in order. I'll talk about this in a second. So my first expression would be if x is smaller than 0, then my abs prime of x is equal to, if it's smaller, that's minus x. And why is this orange? I don't like to see some random underlining. It kind of makes me not trust my Haskell skills, which are not that hot, to be honest. I think that worked. It did. Well, I certainly did an error. So abs prime of 3, abs prime of second. You say like the one after prime is second, presumably. In French it was. That's also free. We're happy about that, right? So this is what's this orange? I can't help you with your pattern matching Haskell. I don't know what I mean. You know, it's orange. It's not red, so I'm happy. Case in point here is that this evaluates in order. So first, I've written them mutually exclusive, right? It's either one of those conditions and only one will be true at any given time. But you can have more than one, right? You can have something like, what if like if it's equal to specifically 3, because I keep testing it to 3, I'm going to return minus 33. Why not, right? And then, so you can do as many as you want, and because we can't enforce that they need to be mutually exclusive, they're tested in order. So first we check for smaller than 0. If that's true, we go into that case, we return the appropriate value, and then we're not going to go to the anything. So you want to write them in the order in which they're tested, and very much like in your switch case, or even your sort of if, elif, else, the last one is often, not always, but it's very good practice to have something to like, if you, as it were, fall through the bottom of the case, is how I call it. For anything else, if it's true, like that will, you want the condition that will always evaluate, because again, you want your function to return something. So there needs to be one of those one of those guard conditions needs to be true. And the best way to guarantee that is to have the bottom one always be true. So if it's true, which means like if I'm here, but I've not matched any of those conditions, so I know that it's going to be the positive case, that's X. So let me run this in and show you. So now it's an underline in gray. Okay, is gray better than orange? Use otherwise, yes. I will explain otherwise in a second. Don't be. I know. It's just you show the first thing. Just to show. Okay, so parameter is 2, but this one 3 minus 33, right? But other positive number fall through the bottom. That's the regular apps. My bad. Fall through the bottom of the true and so on. And in order to make the code more readable, an alias for true is otherwise. That's what it says there in this context. Otherwise, a meaningful alias for true. So it should also be last guard. So it's this idea that suddenly that this is much easier to write. It's much clearer that this is your any other case, your otherwise case. Now, having explained the guards, I'm gonna. Well, I can leave this in. There's a beauty of Haskell is that this is just a function definition. I don't need to worry about that. But I'm going to redo my fizzbus. So my divisible is a bit chunky, right? I've got like between 9 lines of code. Ridiculous. So if I do fbdiv, I'm going to tell it fbdiv of x guard. So x modulo 15, you test, of course, we still need to get the 15 case first, right? Modulo 15 is equal to 0, equal, what was it, fizzbus? Or fixbus? Again, you may want, for the sake of clarity, to clearly style it in with explicit brackets to make sure that first we're going to evaluate the modulo, that's the remainder, and then if that remainder, we're going to test the quality of the remainder with 0, and then depending on the value of that Boolean expression, then this is our return value. Okay, the next one would be with the brackets. Why not? Let's do good practice throughout. If it's divided by about 3 minus equal to 0, then that should be equal to fizz. And finally, if it is, I'm not going to do, well, no, there's going to be an otherwise, actually, sorry, that's not finally, that's thirdly, about 5, 0, that returns buzz, and otherwise, equal show x. This is where, in fact, if you want to be absolutely religious with your brackets, the brackets go here, right? Now, this this does exactly the same thing as that, but in a much neater Haskellian function. So now I just need to divide my fb of n this time, is equal to, I'm going to map fbdiv to a range from 1 to n. Run it in. That didn't yes, because of course my modulo is not written like that. Abort. Mod. It's mod, right? It's mod, and I can write it in infix, and I've made a mistake because I want backticks, not backticks. Oh, sorry, I need to change my keyboard layout. Oh yes, here's my backtick. I have a PC keyboard plugged into a Mac machine, which means that actually, as it happens, the two keys I'm using in this video, this little bit of content, which are the backtick and the pipe, are swapped. Okay, moving on. We've recovered. Right, I can test my FB div individually. So 15 will return fizzbuzz. Right place. Yeah, all right. 9 is the print source, and FB. Up to 20, no, up to 30, so we get another 15 thing, please. Boom. Didn't work because I did. Oh, DB, yeah, I like that it suggests, like, very quickly you will have a lot of functions, and yeah, so it recognized that DB might have been FB, and indeed 1, 2, fizz, 4, 5 bus. So that's BuzzFeed, no, not BuzzFeed. That's the content farm. That's fizzbuzz with guards. Which effectively is now just that. Very elegant, I think you will agree. That was it. Happy coding, take care, and be kind.